The seventh lesson of Chapter 4 is titled Linear and Nonlinear Functions. Remember to take notes on slides where you see stars, and if you need to pause the video to try a problem, make sure to do the work in your notes. You know you have been successful in this lesson if you are able to define linear and nonlinear, and you can identify linear and nonlinear functions from a table or graph. Linear functions can be defined as graphing a straight line and having a constant rate of change. All linear functions have these two things happen every time. If the graph of a function is not a straight line, or there is no constant rate of change from, say, a table, then the function is not linear. That is the definition, then, of nonlinear functions. Nonlinear means there is no constant rate of change, and the graph does not make a straight line. The second goal in this lesson is to identify linear and nonlinear functions from different representations. We will start by looking at a table and deciding if the function is linear or nonlinear. I will model what this answer should look like, including an explanation. Here's the first table. We can determine if the table is linear or nonlinear by finding out if there is a constant rate of change. So we need to find the changes in x, which happen to be 2, and the changes in y, which are minus 15 each time. Is there a constant rate of change? Yes, there is. The constant rate of change is the change in y divided by the change in x, which in this table is negative 15 over 2. You can simplify that or get the unit rate of negative 7.5. So my answer to this problem is that the table is linear because there is a constant rate of change of negative 7.5. Here's the second table. We are going to determine if the table is linear or nonlinear by finding the constant rate of change. We see that change in x is 3 each time. Now let's look at the change in y. From 1 to 16, the change is 15, but from 16 to 49, the change is 33, and from 49 to 100, the change is 51. If we compared the three changes in y divided by the changes in x, we'd see that 15 divided by 3 is not equal to 33 divided by 3, which is also not equal to 51 divided by 3. All three of these values would have to simplify to the same number if there was a constant rate of change, but they do not. So the table is nonlinear because there is not a constant rate of change. Let's take a closer look at the last example of the nonlinear table. We said that linear functions have a constant rate of change and graph a straight line. We can check that this table is not linear by graphing the points on a coordinate plane. We can see that the 4 points would not connect to make a straight line. So using a graph is just one more way to determine if a function is linear or nonlinear. Now pause the video and try these two problems in your notes. Make sure your answer gives an explanation of why a table is linear or nonlinear. The first table would be linear because y is changing by negative 4 as x is changing by 5. The second example would be nonlinear because there is no constant rate of change. Here's another example that says use the table to determine whether the minimum calories a tiger cub should eat is a linear function of its age in weeks. So we need to find out if this table is linear or nonlinear. Pause the video if you think you can do this example on your own, then check to see if your answer matches my answer. If you're unsure of how to do this with me, follow along in your notes and you'll have a chance to do another example in the next slide. This problem is just like the last problem, where we need to find the change in y divided by the change in x and see if all the changes are constant. The age would represent the inputs or x values, so the changes in x for this table are all 1. The minimum calorie intake would be the output values or the y values, so the changes in y would be first 175, then 185, then 135, and then 100. you can see that the rate of change on this table is not constant because the rates of change are 175, then 185, then 135, and then 100, which are not the same values. So this table is nonlinear because there is no constant rate of change. Pause the video and try this example in your notes. Make sure you explain why the table is linear or nonlinear. In this table, there is a constant rate of change of $5 for every one ticket sold. So this is an example of a linear function. In this last example, it says that a square has a side length of s inches. The area of a square is a function of the side length. Does this situation represent a linear or nonlinear function? Explain. First, we need to understand the situation. Let's look at the first sentence, where it says a square has a side length of s inches. That s inches means the side length can be any number we choose. S represents a length, so we only need to choose positive numbers. And since we want to choose easy positive numbers, I think S should be numbers like 1, 2, 3, and 4. The second sentence says the area of the square is a function of the side length. That means, or all that means, is that we can choose the side lengths 1, 2, 3, and 4 to calculate the area. This is a great problem to use illustrations on since we're dealing with area and shapes. So I'm going to draw a square. I'm also going to need to organize my information so I can see the side lengths I used and the corresponding areas I calculated. So I'm going to draw a table. Remember what you know about a square and area. A square has 4 equal sides, so if one side's length is 1, the other side's length is also 1. Also, area of a square is calculated by multiplying the side length times the other side length. So when S, the side length is 1, the area of the square is calculated by multiplying 1 times 1 to get an area of 1 unit squared. If the side length is 2, then the area is calculated as 2 times 2, and the area equals 4. If the side length is 3, then the area is found by 3 times 3 to get a side length of to get an area of 9. And if the side length is 4, then the area is calculated as 4 times 4 to get an area of 16 square units. Now that we've calculated all of this, we want to know, does this situation represent a linear or nonlinear function? And we have to explain. So let's see if there is a constant rate of change. My change in the side length is all 1, but my change in the area, which is the change in y, is 3 and then 5 and then 7, which means this is a nonlinear function because there is no constant rate of change. Here's what the graph of the table would look like. We can see from the graph that this is not a straight line, so it is a nonlinear function. Pause the video and try this example on your own. Remember that perimeter is the distance or length around the outside of the shape. In this case, we are still using a square. If you want to use the same side lengths from the last example, you may choose S to equal 1, 2, 3, and 4. In this example, the function is linear because there is a constant rate of change of 4 for the perimeter as the side length changes by 1. Now that we've reached the end of this lesson, where are you now? Can you define what makes a function linear or nonlinear? Can you look at a table or graph and determine whether or not the function is linear or nonlinear also? If you said yes to both of these questions, then you will be ready to move on to the next lesson. If not, try the guided example problems on page 330 in your workbook and be ready to ask questions in class tomorrow.